Hello and welcome to this video about JSol'Ex 3.0. So I'm quite excited to show you this demo today because basically it took so much time to deliver this, like thousands of hours of work to provide you with new features, improvements, scripting engine improvements, some things like we're going to see the physical flat correction and things like that. So let's get started and show you that in action. So I'm going to start with a file which was provided to me by a user a few weeks ago. And let's go and start with this one. So this file was actually captured using a SunScan. So the SunScan is basically a device which is fully automated. You can capture the disk and process everything using just your phone or tablet. But there's also the ability to take the files and process them externally. So that's exactly what is done in this case. So you take the SUR file and process it. But in this case, the user had a quite severe light leak. So he fixed that after that, but basically there was a light leak and the gradient that you can see here is just horrible. And with JSol'Ex 3.0, basically now there's in the processed solar disk, there's automatic background extraction applied. So now you can see that the result is much better. Unfortunately, in this case, the prominences which are still visible here are removed when we remove the gradient, and that's because it's a particularly difficult gradient to remove. But I'm going to show you that with a second file, which is a much higher resolution file that I took a few days ago using the SAG 700 from MLastro. And the resolution of this is quite it's quite good. It is a large slit and longer focal length than the SunScan, obviously, so you can have quite some details. But if we go to the solar disk as it is there, you can see that it's already quite well contrasted. But if we stretch the levels and saturate the disk, and let's go 22. Yeah, 22. The disk is completely saturated. It starts to show that actually there's a reflection happening. And it would be good to be able to remove that reflection. So if we go to the process solar disk now and do the same, and go like 22 or 24, it's exactly the same. You see that the background has been removed. So that's much better, and you don't have the gradient anymore. However, if you look at the details of this prominence, if we compare the two images, we could argue that there's a bit more detail here than there is here, like some signal has been cut by the background removal. So if this happens, you can still go into the process parameters, and in image enhancement, you have this background level thing there. And if you keep the mouse on the value, it basically tells you what you can do. So it's a value between 0 and 1. 0 means extremely aggressive background removal, and 1 is no background removal at all. So in this case, maybe it removes a bit too much of the background, so I could try to increase that to 0.4 and process again. And when the image is there, we can stretch again, and we see that we kept much more of the signal. However, if we go to the maximum level, so you see that here, you still have a bit of background visible. So it's always a trade-off, like you cannot really remove all the background reflection without cutting some of the signal. So yeah, play with the parameters, change them so that basically they match your image. The default that I have chosen here is just a default which proved to work well with most of my test images. So I have more than 200 files that I usually test with different conditions, different spectrographs, different wavelengths, etc., etc. And this is a good default that I found was working well. So let's reprocess with the default, And now let's go and show you new improvement that we have, which is here the stretching strategy, which is applied on images. So I'm not going to use the process disk to show you the first one. So if I go to just to the raw disk, so this is the disk as it appears just after geometry correction, but the levels, like the stats that you have there, they exactly match what is out of the camera. So the signal is quite good and it's quite yeah, bright for this. However, it has been stretched and you could use no stretch to actually see the actual level which matches that. So it's darker, so you have the opportunity to use no stretch or linear stretch. And then now if I go to the processed version and let's go to the curve stretching, the difference between linear stretching and curve stretching is that basically with curve stretching you can select a couple of points to actually say the lower you go here and the higher you go there means that lower values are going to be enhanced to higher values, so it's going to make the image brighter. But the solution of using a curve is that you're less likely to saturate the disk like you were when you were just using a linear stretch. So in case of a linear stretch, basically it saturates all these bright areas fairly easily. If you go with a curve stretching, then it's not that saturated anymore. So you can play with that and try, for example, to enhance the prominence which are visible there. So more options for you to play with in case you want to just use the software and no external software to post-process the image. All right, so let's go with the second major change in this version, which is about flat correction. So I mentioned that briefly in the intro. And to illustrate that, let's process one file which was provided to me by Min Nguyen from MLHRO, because he's basically designing a new slit which is 10 millimeters wide. And let's go to the demo and flat and select this file, which is very large, and that's because it's a super high resolution image. So let's go to image enhancement, and you see here I have no flat correction applied. And let's see what happens if we do that. So it's going to reconstruct the image, and as we go, you see that it's darker on this side and darker on that side, and that's typical of vignetting. So vignetting, there are many different reasons for vignetting, which are basically related to yeah, the slit width, the optics, which are used by the SAG, so the housing, and also basically the focal ratio of your telescope. So depending on all these combinations, you're going to have more or less vignetting. So JSol'Ex already provided one way to correct for vignetting, and if you already have an SAG 700 with a 7mm slit, it's probably already working quite well for you, but let's show that in action. So I'm going to use open a new window here so that we can compare the images as I'm changing the parameters. So now I'm going to reprocess this file, and in image enhancement, I'm going to use what is recommended if you have this 700 spectrograph. So basically the artificial flat correction, and I'm not going to change the parameters and go with the default. And if we do that, we can already see during the reconstruction that the image is quite the same as before, and that's because it's not done during the reconstruction, it's done after that. And we have an image which is better now, but it's still darker at the poles. Like there is still some yeah, vignetting visible at the poles. And whatever you do with the artificial flat correction, whatever you do, you're not going to be able to remove all the vignetting because the model is too complex for the software to process that. So what is now available instead is that you can take a physical flat. So just compare the two versions of the image for now. So this is with the artificial flat correction, and this was without the artificial flat correction. So again, You see the improvement, but it's not quite correct. The model is not quite correct. So what we can do instead is go to the processing options and select a physical flat correction. And you can select a flat file, and it's basically exactly the same as what you would have if you do deep sky imaging and that you process images with a flat, or even if you do solar imaging, usually you have some flats. And the idea which works well for JSol'Ex is to point your telescope to the sun, and then you're going to put a cap on the front of your telescope with a diffuser, like a tracing paper or some transparent book cover, but like opaque enough so that it filters some of the light, but not all, and diffuse the light as much as possible. And then we're going to take some exposures, like 10 to 20 exposures at 2/3 of the dynamic range, and capture that as a SUR file. And then you select the SUR file, and JSol'Ex is going to create a master file for you. Actually, you can select directly the master file if you want to, or you can select the processed the SUR file. So in this case, I'm just going to use this master flat and do the correction. And this time the correction is applied during the reconstruction. So it makes a big difference because this is the only way you can do that now. And the correction is going to be almost perfect in this case. So we have a great disk, and the vignetting is corrected. So the constraints that you have to use a physical flat is basically that you should use the same cropping window for the flat as what you have when you capture the video. So that's the first constraint. The second one is that you should probably take a different flat at different wavelengths. And that brings me to different use case for the flat correction. Even if you don't have larger slits or even longer focal lengths and things like that. So even if you don't actually see much of vignetting, there is some interest with the JSol'Ex typically to do that when when you're imaging some wavelengths like H beta or sodium lines, because the vignetting is actually much more visible in these wavelengths. So you have typically a much brighter disk around the center if you use these wavelengths, and it's a good idea actually to use a physical flat in this case. The other question that you may ask is when you should actually use a physical flat correction, and my answer would be that as long as you don't have a problem, then you can stick either with no flat correction or the artificial flat correction. Yeah, for example, I was mentioning the other day that for some calcium images which have very low signal level, then the artificial flat correction is not going to work at all, and it's very likely to actually completely skew the data, and you would get a very bad result. So it might be a good idea, actually, in this case, to use a physical flat. So it depends on the conditions, depends on how much time you want to spend on processing and improve the image quality. But it's fairly easy to do. Like again, you just point at the sun, you put a cap, and then you take a SUR file of 10 frames, and that's it. So it's really super simple to realize. So yeah, I hope that you're going to enjoy that. Okay, next topic is something which was also suggested to me by Min, and that's measurements. So basically, a few days ago, I posted an image which I'm going to load. So I'm going to load just a processor file. So that was actually that's this guy. So I'm going to use this load method to load a file which was already processed a few days ago by me, and that's a calcium H image. And this was all processed by JSol'Ex, by the way. So all the stacking was done within JSol'Ex. All the processing to enhance the prominences and whatnot was done directly in batch mode in JSol'Ex. So you can do that kind of things. But yeah, so when Mean saw that image, he said, "Whoa, there's a super large filament here. So it would be cool actually if we could measure that and say what's the length of this guy." So now you have the option to do that. So either you right click and click measure distance, or you can click on this button here and it opens a new window and with a globe, and you can zoom in, zoom out, and you can center on where you want to measure. And then I'm going to start a measurement just by double clicking, and then I can basically go on the disk, and you see that there's a curve there because it basically follows the globe. So I'm going to create some waypoints around the filament and try to follow its path. And let's say that it ends here, and then double click, and I have this measurement which is done. And I can compare it with this guy. So again, I double click, go there, then I go there, here. Let's say I stop here. So always say, how can I stop the measurement now that I moved? You can just press enter and it just finishes. So you can see that this one is basically twice as long as this one. And you can do that. And the other thing that you can do is that you can go outside the disk and say that you want to measure that prominence. You can again double click here and go here and press. And the difference is that when you're outside the disk, it's just a linear measurement, so it's much less precise because basically we don't know how far is the prominence compared to the rest. So again, we can do that and measure this guy, and then I'm going to stop the measurement. And let's say that I'm happy with that. I can say save that, and in my demo, I'm going to create a file which is my measurement. And then when I move here, now I have this image which is created with all the measurements that you can share. So it's quite cool feature. Thanks to Min to suggest this. It was really a good idea and it was quite fun to implement. So nice. I hope that you're going to enjoy that again. All right, the last thing I want to show you in this video is basically for more advanced users. So I mentioned that in the beginning, but basically the scripting engines that I just used there to load an image, basically this scripting engine has been much improved in this version. So let's go and say that I'm going to process this file. And there we go. So we have one file. So you know the script engine is basically something which lets you do like image 0, and then when I do that, it gives me the image unmodified, no stretch whatsoever. And then you could say perform some auto contrast on this image, and then let's say 1.5 as the gamma. And now we have this image which is modified. We could decide to invert this, which would not look very nice, but let's see, like invert. So yeah, this is not nice, and that's because, yeah, basically inverting a stretch image is not a good idea. Anyway, so I can go back, and so this is basically the idea of scripts. And so you see that there the concept is that you have some functions and then you pass some arguments. And sometimes what could happen is that you'd say, I have this first image, which is, let's say, the on bend. So it's on bend because it's at pixel shift 0, so it's in the middle of this calcium line. But I could also decide to do an off-band image and do the same, so auto contrast image. And then here I would basically say like -5 pixels and then 1.5. And it would generate a couple of images, one which is unbanned and the other one which is shifted by 5 pixels. So 5 pixels is nice, but sometimes you just want to use angstroms instead. So you could use A to px, like angstrom 2 pixels, and let's say that I want to shift by 1 angstrom, then you can just do that, and it's going to compute the pixel shift for this, and you see that it's not 5, it's actually 7.38, and then you have an image which is just shifted by 1 angstrom. So you have some new functions like this guy. I'm just going to come back to these 5 to illustrate another improvement of the scripting engine, which is interesting here because actually I'm duplicating the same chain of things like auto-stretch an image with this parameter. So what we can do now is that we can declare some functions. So now I'm going to say fun and declare a function which is enhance. That's the name of the function that I create, and then it takes an image as a parameter. And the result of this image is just auto contrast of the image with 1.5. And then I need to declare the output section now. And instead of using that, I can just provide here enhance. So I'm going to enhance and just I can remove this parameter. So this guy is going to be passed as a parameter to the function. So image is going to be image 0 or image 5. But now I don't repeat these every time. So I can run that. And we have the same result. It's just that you just reused that. And the cool thing is that if you have multiple functions like that that you want to share between different scripts, you can actually externalize them and import them in the script. So I could have that in an external file and do something like import here, import, and then utils.math, or utils, actually it's just utils. And it's basically red because it tells you that utils doesn't exist in this case. But yeah, that's the thing that you can do. So you could move that into a file, remove that, and then you could share these utils files between different files. But let's go back to this version. So let's say now that I change here the name of the parameter that I use, let's say A. So now this guy is in red because A is not defined, so I can use A. But what I can do is use named parameters. So now I can use A and here A also. So named parameters is a different way to pass the arguments to a function. And all the built-in functions have parameter names now. And sometimes you had some functions which had quite a few parameters and you didn't quite know in which order you should put the different parameters. So now the fact that you can have some names on the parameters, you don't care anymore. You just pass the names of the arguments, and then JSol'Ex is going to be do the mapping automatically so that you can call the function as required. So yeah, pretty nice. And the next example that I'm going to show you of the improvement is just to show you one of the many different functions which have been added. And I thought it would be cool to show you that because I had a blog post about that, but there was a partial eclipse in March, late of March in France. And I used my SAG to process that. And I have selected a few images there, so I'm just going to go and open one file for now. And we're going to see that. So I used the batch mode, so it was a good idea, but I can use that. So you see that it was, yeah, basically the moon is coming. So interesting event to follow. And now I'm going to use the batch mode to process these all files to create an animation. So I'm going to open that and then select here image math and open the script and load the script that I have prepared, which is this animation. So basically what I'm going to do is that all the different files, I'm going to apply a contrast enhancement with this 1.5 gamma on the image. So all the different files are going to generate one image called base. And then at the end of the batch, we're going to sort all these images, or all the base images by date, so that we can do an animation which is based on the date, so that it's done in time. So we just sort and then we create an animation, and 20 is there's basically the amount of time spent between the different frames. So if we run that, let's we don't care about the other images. It's going to start processing these 5 files. And so if we look at base, we have all the different images that we are going to use. And the idea is that in the end, thanks to this anim method, we have this animation created. So it's a bit fast, so we can say 200 and run again. And now we have 200 milliseconds between the different frames, but it's not uniform. So you see that we have some background, some brightness which is not uniform, and that's because of the disk, which is basically skewing all the data. So it would be good to improve that. So there's a second version where basically I have this new equalize method, and it takes the list of images and basically equalizes all the contrast and brightness of all these images. So if I run that with equalize instead, now it's going to be a bit better. So you see that there's no flickering of the brightness, which is already much better. But we can do still a bit better because what would be nice is actually to create and interpolate between the different frames, because basically I took an image once every 5 minutes, something like that. It was not precise because there were some clouds, so sometimes I just skipped some frames, etc., etc. But what I can do now is use this transition method, and what it takes is the list of images that we have as an input, and then it generates 10 images between each of them. And you see that in this method call, I basically used the named arguments in this case, like the list of images that I want to use, the number of steps, and then the transition. So let's again use 200. No, we're going to use 20 because we had one image, but now we're going to have 10 times more. So if we want the animation to last as long, then we need to reduce the delay by 10, by a factor of 10. So run this. So it creates all the interpolated frames, and now we have something which is smoother. And the last thing I want to show you is that there's even a more advanced parameter that you can use in the transition, which is the unit. And in this case, if you specify images per minute, IPM, images per minute, it means that the 10 here means that there should be 10 images per minute between each image. So if there's 5 minutes between two serve files, then you would get 50 images. But if there's only 2 minutes between two different serve files, then you would only generate 20 images between these two. And basically this lets you completely make the animation uniform over time, because it will automatically compute the number of images that you need in between. And then if we run that, the animation is going to be uniform over time. So that's the best that you can do, basically. And if you're interested in that, I showed the result of this animation on my blog, and there's a YouTube video, and you can see the whole eclipse over the day. All right, so that's basically all I had for today. I hope that you're going to enjoy this new version. Again, do not hesitate to report problems that you face, or not, yeah, just if you don't want to report problems, but simply say thank you or whatever, I take it also. And you can do that typically going into the help channel. You have this Discord community that's something that I created a few releases ago, but you have a direct link if you want to join, or you can use GitHub, or yeah, you can also ping me on email, whatever. So thanks for listening and enjoy. Bye bye.